Good morning. Myself, Ayushi Prajapati, and today's my topic for presentation is flame model. Here are the table of contents that I will be covering. First is description on flame, brief explanation of it, how the model works, its capabilities and features and aspects. First of all, what flame stands for. It is a faces learned with an articulated model and expressions. It is a lightweight and expressive generic head model learned from over 33,000 of accurately aligned 3D scans. Flame combines a linear identity shape space with an articulated neck, jaw, and eyeballs, pose-dependent corrective blend shapes, and additional global expression blend shapes. In the vast landscape of technology, Flame is the bridge builder linking industries as diverse as entertainment, medicine, and artificial intelligence. It paves the way for immersive gaming expressions, facial recognition breakthroughs, and even medical situations that train tomorrow's healers. Imagine flame as a digital sculpture, capturing not just the outer visage for the underlying anatomy, but also the muscles and the very essence of facial identity. It's as if it breathes life into polygons and vertices, giving birth to characters that resonate with authenticity. The flame is the artisan behind the mask, enabling individuals to craft digital personas that are as unique as fingerprints. It empowers personalization and self-expression, making each character as distinct as the humanity merits. Brief explanation of flame. It is an articulated model, which means it can represent not only static facial shapes but also the dynamic movements and deformations that occur when a person speaks, smiles, frowns, or make other facial expression. So it specifically recognizes your whole expressions and evaluates it. This makes it useful for the applications like facial animation and expression synthesis. Also, it has expressive capabilities representing a wide range of facial expressions and emotions. It can be used to generate realistic facial animations for characters in video games, movies, and virtual reality environments. It computer vision and research. Flame has application is computer vision research including face tracking and recognition. Its detailed representation of facial geometry can aid in tasks such as facial landmark detection and emotion recognition. Flame can be customized and adapted to specific individuals by fitting the model to a person's facial features. This customization makes it possible to create personalized avatars or characters for various applications. As you have seen, there are many movies that are animated, and it is like excellently done. Like we have one movie Avatar. Then how the model works. So it flame represents the human face in 3D space. It captures the detailed geometry of the face, including the shape of the skull, muscle structures, and skin. The model is a parametric, meaning it uses a set of parameters to define the shape and appearance of the face, and it is adjusted to generate different facial shapes and expressions. It is an articulated structure as mentioned before, so which means it takes into account the articulation or movement of facial components like the jaw, lips, and eyebrows. It includes a deformation model that can simulate how the face changes when different facial expressions are made. This involves changes in muscle activations and their effects on the skin. It is an expression synthesis. So its ability to synthesize a wide range of facial expressions, it achieves this by adjusting the parameters of the model to represent different muscle activations and facial deformations associated with various expressions. For example, to creating a smiling face, Flame adjusts the parameters to simulate the muscle contraction and the skin deformation that occur when a person smiles. And it is a customization model. It represents the specific individuals. This is done by fitting the model to a person's facial features, often using images or 3D scans of the individual's faces. It involves adjusting the model's parameters to match the unique facial geometry of the person being represented. Applications. Flame is used in a variety of applications such as video games, movies, virtual reality, where realistic facial animation and expression are essential for creating lifelike characters. It can also find the applications in computer vision tasks such as facial landmark detection, emotion recognition, and face tracking, where the detailed facial geometry can aid in accurate analysis. So, for building the model, we should know the capabilities of it. So, first is high fidelity textures. Flame incorporates high quality textures for realistic skin color and surface details. Then it is a statistical model. So it is based on a statistical model learned from a large data set, allowing it to generate various facial shapes and expressions. Then comes real-time application. Flame is optimized for real-time applications, making it suitable for video games and virtual reality. Its capability is inverse rendering, which it includes to estimate the parameters from 2D images or videos of a face. Then research contributions. Flame has made significant contributions to the computer graphics and computer vision research. It is an open source. Flame is often available as open source software. Then integration with other tools, with popular animations and rendering software. Then scalability. It is adaptable for different levels of complexity. Also facial rigging. Flame simplifies the process of creating facial rigs for animators. And lastly, interdisciplinary applications. So in medical simulations and surgical training, it can be used. The aspects and features of the Flame model. So it is a data-driven learning. Flame utilizes a data-driven approach, learning from a diverse data set of 3D facial scans and images to capture the natural variability in human faces. Also, it is a realistic skin simulation. Beyond textures, Flame can simulate realistic skin behavior under different lighting conditions, enhancing the overall realism of facial models. Also, facial landmark detection. Flame's detailed facial geometry makes it suitable for facial landmark detection tasks, which are essential in applications like facial recognition and augmented reality. Then expression transfer. Flame can transfer facial expressions from one person to another, which has applications in character animation and impersonation. Also, age progression and or regression. The model can be used to simulate how a person's face might change with age, which has application in forensics and entertainment. Also, emotion analysis. With expressive capabilities can be used in emotion analysis, helping to recognize and analyze emotions in human-computer interaction scenarios. Last, facial reconstruction can be employed for facial reconstruction from incomplete or damaged 3D scans, contributing to forensic science and archaeology. Conclusion. So in conclusion, I would like to add that our modeling framework provides reasonable solutions for most of these issues and facilitates a seamless transition from model development to model production with little effort. So, models can be easily maintained, stored, exported, and imported. Flame uses innovative methods to combine models by building models based on the results of the other model. So this adds unique flexibility for combining multiple models addressing the same endpoint or combining models representing multiple mechanisms contributing to the same endpoint in the toxicological field. So thank you.